and also finding a rotational by using a virtual work method for variety types of structural systems. So here, when we talk about the variety type of structural systems, we know that in chapter 1, we have beam. We also have truss systems. Okay, and we have a frame structure. And then we also have another one, what we call as a composite structures. And so far, what we have learned, okay, we have learned about beam and we have learned about truss. All right. So in truss systems, again, here the ultimate objective in chapter 1, okay, we wanted to determine a vertical or a horizontal displacement. We can say that we wanted to determine displacement, all right, displacement at any point along the joint, any point along the truss, along the beam, along the frames, or along the composite structures, finding the displacement by using virtual work methods. So far, we have learned about truss systems. So to find the truss systems, so we have n equations. So can one of you tell me what is the equation to determine a displacement for a truss structure? Anyone? Come on.
1
Hello? Anyone?
kilonewton times
Okay, 1 kilonewton times
displacement
displacement equals to
equals to summation of
summations of
capital Ni
capital Ni
and I
and I
L over AE.
L over AE. All right, thank you. So that is for truss systems to determine displacement. Okay, so now in terms of beam, okay, in terms of beams, I have explained to all of you previously that there are two ultimate objectives in beams, whereby we can determine a slope or a rotations, or we also can find um, what we call it displacement. Okay, a slope or displacement. So can anyone give me what is the equation needed to find the displacement in beam? Anyone? Shall I call the name?
Displacement in beam. Displacement in beam
Okay,
is
tell
1 kilonewton times
1
displacement
kilonewton, okay,
times displacement
times displacement
equals to
equals to
uh, capital M over EI,
M I
smaller smaller
M
m over EI,
I over E I
and then we integrate
dx,
dx
0 to,
L.
all right. How about slope? Can you pass your friend's name? I mean,
Saya
yes.
1 kilometer
1 kilonewton meter
time theta
theta
equal to integrate
integrations of,
0 to L.
okay,
So
wonderful,
M besar,
okay,
M kecil
all right,
bahagi EI
definitely
D theta.
d theta. All right. So far, thank you for all the one who answered the questions. So far, this is the one that we have learned throughout the semester. Okay. And remember that I told you the frame, in order for us to find the frames, okay, it is similar to what we find for a beam structures. It means that in frames, we also use a virtual work method in order to find a slope and displacements. And for a slope and displacements, we also use the similar equations as what we have applied in beam structures. Okay, so that is one thing. And another thing, so now what is left for us, okay, for what is left for us to cover today, okay, so our plan today, okay, my plan today, all right, first I will go through and look into the solutions of the questions that I have given to all of you last class, whereby I asked you to get a analysis and find a displacement for a beam. And I asked you to make a comparison from the solutions that I have given to you. Okay, so we will recap into the previous examples. Okay, recap previous examples for beam. Okay, and secondly, okay, first we recap previous examples on beam, and secondly, what we will do, okay, we will look into a frame structures. One examples for a frame structures. And if we have enough time, we will look into a composite structures as well. Okay, so now, if you still remember, in the last class, I gave you this. Okay, I give you this, what we call it, these questions, whereby I asked you to solve for a beam which carrying a triangular load in both sides, where you have a fix at A and a roller at C. So as for today, because last time I did ask you to do it and I did ask you to make a copy of it so that I will call among of you to present on how you get the solutions. Okay, so I will stop presenting because I will allow one of you to present. Okay, I mean, just now you have answered. Can you nominate one person, anyone in this Google Classroom, Google Meet, to show their solutions and explain to us how to solve it? I mean, can you name one?
Anyone?
Just
Afiq
random.
boleh.
It's not
Afiq boleh.
necessarily, it's not necessarily from our class or from the R2. You can pick randomly, up to you. Who
Afiq
is
boleh.
your no?
Afiq
Sorry?
boleh. Afiq, Afiq.
Afiq. Okay, Afiq. Afiq. Muhammad Afiq, is it? Muhammad Afiq, are you there?
Yeah, doctor.
All right. Can you share your screen and please explain to everyone how to solve the questions?
Which one, doctor?
The one that I gave it last class, which is with the triangular load.
Oh, I just did halfway, doctor.
Didn't I ask you to complete all?
Yeah.
So I don't accept any unacceptable reasons. So can you show it to me halfway that you have done? Afiq, can you make it quicker? The rest, can you please stand by with your solutions? Afiq, come on. I think I have give all of you ample of time to solve the questions. And as per day one in class, didn't I mention that you have to complete and give your full commitment to the one that I give it to you in class? Afiq, are you there?
Yes, doctor.
Can you
Wait,
share
yeah,
it now?
doctor. Okay.
Can you please share now, Afiq?
Okey, doktor saya bagi kat doktor boleh?
Okay. But you have to explain it. Where is it? Afiq, mana jawapannya? You share kat mana?
Dalam grup doktor.
Okay, hold on. Let me check. It's not very clear, but yep, we can have it. So I want you to explain to us. So I will share the screen and you have to explain the solution, okay? So what should we do for these solutions? I hope everyone can see it. Let me download first. Okay, Afiq, can you please explain to us what is this question is all about and what are you going to find? Afiq,
Ya doktor. Sekejap
okay? Come on, we are waiting. Afiq, are you there?
Doktor. Ya.
Okay. Okay.
Uh, apa ni?
Explain to us how did you what are you doing here? What is this? What is the procedure? What are you trying to find? Come on.
First, saya just cari momen dia, momen untuk both tu, penung tu, yang hujung tu,
Mm-hmm.
and then lepas tu dah cari apa nama tu, salah.
What is it?
Hmm,
Come on, Afiq.
Force ke? Mula mula Afiq buat cari momen dekat B dengan momen dekat A. And then lepas tu Afiq cari force untuk VA. Force dekat VA. Sebab DOI yang Afiq dapat adalah kosong. That's why Afiq guna method 2 momen 1 force. Macam tu lah.
Method 2 moment 1 force. Apa maksud itu?
Macam mana?
Afiq, you have
Ah,
to explain it clearly, Afiq. You are in big trouble. Okay, never mind. So, but Afiq, are you there?
Ya, doktor.
Okay, can you please see me personally? Okay, next week on Monday. Please bring all the solutions, okay, that you have, because I really want you to do it and I wanted to see it. Okay, and at that time, make sure you able to explain what you have done. Okay, Afiq?
Okey, doktor.
Okay, all right. So anyone else? Can I call um Ahmad Nazmi? Can you please share your solution and explain to me and to everyone how to solve it? Ahmad Nazmi, are you there? Ahmad Nazmi? Ahmad Nazmi Ashraf, are you there? You are not there, don't you? Or are you, what are you doing? Ahmad Nazmi? Ke tandas? Okay, so I will call Nur Wafikah. Nur Wafikah Abdul Rahman. Can you please share your solution?
Alright, doktor.
All right, good.
Saya hantar dekat grup
Okay. Which group? R2 or C1?
C1.
Okay.
Sekejap doktor, saya cari file.
Okay, come on.
Dah doktor.
All right, I will have a look. Okay, so I will share my screen and please explain to us. So what is the question is all about and how you solve it. Okay.
Okay. Firstly, I try to find the reaction force for horizontal and vertically, and
What
then
is it? VA, So you are finding the
yes,
okay.
and then I use formula centroid distance for to find vertical force, and
Mm-hmm.
then I try to find moment using the formula centroid distance times the lot itself, and then I
Mm-hmm.
got those answer, and then I try to find the big M and small m
Okay.
for each member
Okay.
from 0 x3 and 3 x9. Then I try to find moment for each of it
Okay.
and find mx for both of with real structure and virtual.
Okay.
And then I use calculator to find the solution using the 1 kilonewton displacement and then mmei dx.
Okay. So this one, are you calculating yourself or you simply
Uh,
you
uh,
use calculator?
at first I use the calculator.
Okay, good. Because again, at this particular point, all right, so it is advisable for you to use a calculator, because as I said, when you have these equations and then you write an input for the uh, real moment and the virtual moment, and then you just simplify those, so you will just get only 1 marks. So it means that to finally get the answer, you need to use your calculators and then you will get the answers. So have you compared your answers, your solution with the one that I have shared in the WhatsApp group?
But doctor only send the first example question. I mean the first question only.
Okay, I didn't share this one.
Doctor didn't share this one.
Okay, all right. Okay, thank you very much, Wafika. Okay,
Okay, you're welcome.
all right. So, the rest, have you completed yours? Okay, I'm unable to see it and check it one by one, but if you are really wanted to understand and get their solutions right, so you have to do it. Okay, thank you for those who give your emoji. So now let me explain the solutions. Okay, thank you. Okay, so for this one, so basically here are the questions given to you. Okay, and of course, there will be a variety types of loading that will be given to you um, during the exam later. So now, all right, so now you were given a beam, okay, a beam. And what is the unique about this beam is that you have a hinge. Okay, you have a hinge. So in this case, okay, so basically you have a triangular load, okay, that have distributed along the span. Okay, and we can see that this triangular load, all right, so let's have a red color. So you have beam A, B, and C. So here is 5 kilonewton per meter, and here is 7 kilonewton per meter. And the length of the beam, all right, so here you have a hinge, and then you have 6 meter, and then you have 3 meter. All right, so rule number one, okay, when you were given this type of questions, as I said, look into it and think how to cut the section. Okay, so first, you know that the question asks for a vertical displacement at B. Okay, to find vertical displacement at B. All right, to find the vertical displacement at B. So in this particular case, definitely you need to um, what we call it, find the reactions. Okay, so to find the reaction forces, so you have a hinge here. Okay, so what is the meaning of getting the hinge in at B? So apa fungsi hinge tu? Apa fungsi hinge? So hinge, okay, take note everyone, when you have a hinge, it means that the moment, okay, the submission moment at hinge is equals to 0. So maksudnya jumlah moment dekat hinge dia adalah kosong. And the reaction forces dekat hinge also will be 0. Okay, sebab kalau hinge tu tak kosong, maksudnya kalau you ada hinge kat sini, if you have this, okay, and then you have beam B, and then we separate it, okay, here, reactions. So basically you ada A kat sini, you ada B, and then you ada B, you ada C. Kalau you separatekan dia lah, okay. So dekat sini dia kena equilibrium. Maksudnya dia punya forces tu kena 0. What does it mean? It means that so you ada kat sini, you akan ada VA. And then you will have the whole lot of your triangular load, which is 7 kilonewton per meter. Okay, you have 7 kilonewton per meter. So dekat sini you ada, kalau you lukis free body diagram, you ada VA, and then here you akan ada VB. So here you have the other one, which is you ada macam ni. So here dia punya load dia adalah berapa? Load dia adalah 5 kilonewton per meter. So when you actually cut the sections, okay, you akan ada VB, and then you akan ada moment. Okay, you akan ada moment. So I will make the moment into the other colors so it will not confuse all of you. So kita tukar color. Let's say kita ada color blue. So you have dekat B you akan ada vertical, and then you akan ada sini you akan ada moment lah dekat sini. Alright. So moment at B, and then kalau dekat B sini moment ni dia kenalah berlawanan arah MB juga. So maksudnya total moment this one plus with this moment, so dia akan jadi kosong. Samalah juga dengan vertical forces. So if you have that VB, so whatever VB yang kat sini ke atas, VB sini dia kena jadi ke bawah. So in total, so here you will get your reaction forces VC. So in total, when you analyze the structure, okay, what you may find that at B, you akan dapat vertical forces akan equals to 0. Maksudnya VB minus VB, you akan dapat kosong. And then negative MB plus MB, you akan dapat kosong. So sebab itulah dekat hinge, okay, when you calculate, you will find out that the moment at hinge will be equals to 0. Okay. So bila moment at hinge equals to 0, okay, so you can make an advantage of analyzing the beam at hinge. Okay, so maksudnya dalam case yang ini, apa yang you boleh buat, so kalau kita nak cutting the moment section, so how many options that we have? Can anyone tell me how many options that we have in finding the sectional moment? Anyone?
3 options.
3 options. Okay. So for this particular example, let me copy this slide. Okay, we duplicate it. Okay. So for this example, so what is the possible solutions that you can have untuk example ni? Okay, kalau you akan pilih cutting section macam mana? Sebab sekarang ni you dah dapat this loading. So of course, first of all you kena cari apakah VA. You can check your reaction, what is your VA, what is your VB, and what is your you may find VB or you may not find VB. It's up to how you find all the reactions. Tetapi yang kita nak dapat dekat VA dengan VC lah. Okay, let's say kita nak cari dekat VC. Alright, VC. So dalam kes ni, I'm sure that everyone understand how to calculate the reaction forces. Okay, so let's say kita dapat VA. VA kita adalah berapa? 2.6 ke 26 Kejap VA kita adalah 26 kilonewton. And then your VC will be equivalent to 2.5 kilonewton. Alright. So, up till this point, may I know who are still not clear on how to find the reaction forces when you have these types of particular loading? Boleh tak you angkat tangan ataupun okay. Yes, Farizal? Okay, so you
Kalau untuk structure yang ada hinge, saya
okay.
kena lukis balik ke? Kena lukis diagram baru ke untuk dah cut hinge dia? Ke tak perlu?
Okay, tak perlu sebab bila you ada hinge structure like this, okay, sekejap So let's say we have kejap. So you have this one. Okay, I akan copy balik this one. Everything will be copied. Hold on. Okay, kita ambil another baru. So kita letak sini. So untuk this one, okay. So you ada macam ni. So kalau nak cari reaction forces, okay, dia ada dua cara nak cari reaction forces dia. Okay, untuk nak cari reaction, okay. Oops, sorry. Okay. So untuk nak cari reaction forces, okay, yang contohnya bila you ada gambar ni kan. So dekat sini you boleh carilah you ada VA and then you ada VC. Okay, you ada VC. So cara pertama nak cari reaction forces, okay, cara pertama nak cari reaction forces, you boleh cari macam ni. Okay, you boleh cari macam biasa, you boleh buat submission moment at A clockwise positive equals to 0. Okay. So dalam kes ni, apa yang you akan cari? You akan cari you ada VC macam biasa. So you ada VC, you darab dengan panjang. So ingat moment adalah forces yang perpendicular dengan your displacement. So in this case, you have VC, you multiply with the distance 9 meter. Okay, you darab dengan 9. And then you have the 5 kilonewton per meter punya load kan. So untuk 5 kilonewton per meter punya load, so you will add plus, okay. You akan ada 1/2 darab 3 darab 5 and then you akan darab berapa? So dekat sini you akan ada, here is 1/3 ke 2/3?
1/3.
1/3. Okay, here is 2/3. So maksudnya setengah kali tapak kali tinggi adalah you punya force. Okay, so this one is your force. Okay, force. And then you baru nak darab dengan distance. So your distance adalah berapa? Siapa boleh beritahu what is your distance?
2/3 darab 3.
1/3
1/3 darab 3.
darab dengan 3, betul tak? Campur?
6.
6. Yes, I sukakan semangat tu, campur 6. So then you ada this is your distance. Okay, so your force, this one is your force kilometer per meter darab meter. So this one is your distance. Okay, your distance. And then you akan tambah lagi apa lagi yang ada? You have another triangular load. So you plus with, again, you akan ada setengah, okay, darab tapak. So what is your tapak sekarang? You punya tapak adalah 6, okay, darab dengan load 7. And again, this is your force. Okay, force nak darab dengan distance. So now your distance would be 2/3, isn't it? 2/3 times with 6. And then equals to 0. So here would be your force and here would be your distance. So nanti you akan dapat you punya VC. VC you akan dapat certain value. Ini one of the options how you wanted to find your what we call it, your reactions. So bila you dah dapat VC, so you akan gunakan yang submission forces vertical upward positive equals to 0. So in this particular case, you akan ada VA. Alright, so you perlukan VA and then minus setengah darab tapak.
Madam,
Yes.
kan momen dekat A tu kan?
Tertinggal. Betul lah. I tahu. Ini crash tu kan? Kejap
Barulah.
Suara dia I kenal. Okay, kejap. So, betul. Tertinggal. So, you have a moment at A. Okay. Good job. Thank you. Alright. So, you have plus MA. Okay. So, nanti dekat sini, you akan ada MA. And then you akan ada VC juga. So once you get MA, so sekarang you dah ada dua lah. You ada MA dengan you ada VC. So bila you dah ada dua equation macam ni, alright, another way you can do, you boleh ambil daripada hinge dahulu. Okay, so bila you dapat option yang macam ni, so you akan jadi susah lah nak solvekan dia sebab you ada VC and then ni kita buang dulu. Right, kita buang dulu. Okay, kita buang. So, kita dalam equation ni, you akan ada equation VC dengan you akan ada equation MA. Alright, so in this particular case, so you have your, dalam this equation, you akan ada VC something plus MA equals to 0. So, you dapat dalam satu equation macam tu. So, bila you dah dapat dalam equation macam ni, what you can do, okay, then you can make use of your hinge. Okay, you can make use of your hinge. How to make use of your hinge? So, you boleh cut, you boleh ambil bahagian, contohnya you boleh ambil bahagian sini sahaja. Which is bahagian CB sahaja. Okay, so bila you ambil this bahagian sahaja, now you can find what is your VC. Okay, so to get your VC is very straightforward. So you just can have submissions, forces, vertical, upward, positive equals to 0. So in this particular case, what you will have, you akan dapat setengah darab dengan you punya jarak 3. Okay, setengah kali tapak kali tinggi, which is you have 5 kilonewton. And then you plus dengan VC equals to 0. So now you get what is your VC sama dengan the value. So bila you dah dapat this VC, you can put in here and then you will get your MA. So bila you dah dapat you punya MA and then you dah dapat you punya VC, you can use the same formula which is summation of forces vertical positive equals to 0. You boleh guna summation forces vertical positive equals to 0. So you will have VA plus VC minus half times with 6 times with 7, okay, minus half times with 3 times with 5 equals to 0. So dekat sini you dapat VC, let's say lah your VC is A. So VA plus A and then you will get 0. So here you can get your VA. So ni one way of how you solve in finding the reaction forces. Ataupun satu cara lagi, okay, another way how you going to solve this, Okay, I will duplicate.
Madam,
Yep,
nak tanya,
yep.
kan kita cari VC pakai right hand side sebelah hinge tu kan?
Ni, okay.
Kan ada yang Madam label VB tu.
Okay.
Yang VB tu kita boleh ignore
VB ni sebab nanti VB ni you perlukan bila you nak kira untuk katakan sebab nanti you nak dapatkan semua you punya equation kan. So selalunya VB yang you dah dapat, kalau you dah cari VB kat sini, so this VB dia akan transfer kat sini sebab you nak cari you punya VA kat sini. Faham ke?
Faham?
So you dah dapat VC. So bila dapat VC, you boleh kira what is your VB. So daripada VB, you transferkan kat sini and then bila you nak kira MA tu, tapi dalam case ni, kita dah dapat all kita punya value. Dah dapat, maksudnya bila you kira VC sini, you akan guna equation daripada C sampai ke A. Tapi kalau you tak nak guna equation C hingga ke A, loading dia, you mungkin boleh kira, kalau you nak kira pada B sahaja, so your VC, VC you ni, you kena carilah VB berapa, transferkan VB tu kat sini, so VB tu yang kira untuk what is your moment dekat A. Itu pun boleh juga. Dia ada banyak cara. Faham ke?
Faham.
Okay. So cara yang kedua, okay, yang ini cara yang pertama. Maksudnya kita dah tulis semua equation and then kita cari VC, masukkan dan sebagainya. Okay, cara yang seterusnya, you boleh dapat, okay. Okay. Cara yang seterusnya, apa yang you boleh kira adalah, you calculate hanya melalui ini. Maksudnya, bila you dapat hinge, you separatekan dia kepada dua bahagian. Maksudnya you ada VA, you ada VB, you ada MB, you ada VB, you ada VC. So dalam kes ni you boleh kira satu persatu. Sebagai contoh, kita kira yang bahagian BC dulu So kita akan dapatkan reaction VC lah. So dekat sini sama macam tadi, you akan guna submission forces vertical upward positive equals to 0. So dalam kes ni you akan ada setengah kali dengan 5 kali dengan 3. Alright. And then you have plus VC sama dengan kosong. So then you akan dapat berapa you punya VC lah. Okay, let's say you dapat you punya VC. So in this case, bila you dah dapat VC berapa, okay, so then you nak tahu VB you berapa. So untuk nak tahu VB berapa, so you can calculate your submission forces, okay. Maksudnya VC ke atas, okay, positif. So you akan ada VC minus setengah kali 5 kali 3 minus VB, you akan dapat. So this VB, okay, this VB, bila you dah dapat, you akan transferkan VB tu kat sini and you use the same VB untuk kira the what we call it, the moment at A. So maksudnya untuk this one, you akan dapat lah. Okay, you akan dapat your VB, okay, VB ke atas darab dengan 6, okay, negatif, VB darab dengan 6, campur, you ada setengah kali 6 kali 7 darab dengan, you ada 2/3 daripada 6, okay, 2/3/6. And then do you have anything? You have MA. Ikut jam plus MA equals to 0. So VB you dah dapat kat sini, masukkan VB. So then you akan dapat what is the value of MA. So finally, you can calculate submissions of forces vertical, positive equals to 0. And then VA plus VC equals to 0. VA sama dengan berapa. So dia ada macam tu lah caranya. So bila you look into the solutions, okay. Oops. This one. Sekejap This one. So here you have the solutions, okay. So you boleh calculate as a whole atau you boleh calculate as a half. So in here kalau you tengok you can have the right hand side. Untuk yang ini kita kira right hand side submission moment at B pun boleh juga. You ambil moment dekat B. Another cara. In here you boleh buat, you have the loading. So you have this. And then this is a hinge. So you ada 7 kilonewton per meter. You have the hinge here. Sini you ada A. And then you ada hinge B. So dalam kes ni, you nak cari you punya VA. You guna cara macam ni pun boleh juga. So sebenarnya what I'm trying to say, you have many ways on how to get the reaction forces. Depends on your understanding. Maksudnya depends on cara manalah yang you rasa mudah nak buat, yang you boleh guna pakai. So here you have VA, okay, and then you have MA. Alright, so you have in here from the right hand side. Alamak, ni left hand side. Sekejap salah lukis pula lah. I wanted to draw actually right hand side. Okay. So kalau right hand side, okay, so you have this one. Okay, you have 5 kilonewton per meter. And then you ada roller. Okay, and then you have the B kat situ. So kalau right hand side, samalah. You akan dapat here your VC. And then you ada moment at B. So moment at B, you know is equals to 0. So you can have submission moment at B clockwise positive equals to 0. So you boleh dapat negative VC. Distance kat sini adalah 3. Negative VC darab dengan 3. And then ikut jam, campur setengah darab tapak darab tinggi. So this would be your force. And what is your distance? Distance adalah 1/3 from the centroid. So you darab dengan 1/3 darab dengan 3. Okay, and then equals to 0. Because we know that MB here equals to 0. So now you get your VC. Dan seterusnya, you pun kira lah, you dah dapat your VC. And then you can use your VA to find 26. And use submissions moment at A because you already know what is your VC is. You get your M. 114 kilonewton meter. So untuk reaction yang ada hinge, I hope by now semua orang jelas. Boleh? Can you show some emoji if you really understand it? Okay. Alright, good. Thank you. Okay, so now so far semua dah dapat lah maksud macam mana kalau ada hinge ya. Okay, kita teruskan. So once you got your hinge, so the next step would be your calculations lah. Okay, Maksudnya kita akan kira your equations. Okay, sebab soalan ni dia minta vertical displacement dekat B. Okay, and then we get this. Okay, so kita nak vertical displacement at D. So kita macam biasa, kita tahu equationnya nak dapat vertical displacement. So equationnya adalah 1 kilonewton displacement at B vertical equals to integrations of 0L capital M I smaller mi over EI dx. So kita tahu kita kena draw. Of course this one you kena buat satu. And second step what you have to do, you need to draw the real structure. Okay, real structure. So real structure will give you capital M. So here the capital M would be like this. Okay, you akan ada this one. And then kita ada hinges kat sini. You have this one. So this one. And then also you have here. So here is 7 kilonewton per meter. And here is 5 kilonewton per meter. So now kita nak cari dia punya ni. Ini kita dah tahulah. So kita ada dekat, we have A, we have B, and we have C. And kita tahu dekat A tadi, reaction forces kita dah dapat VA 26 kilonewton. And then kita ada VC kita here, which is 2.5 kilonewton. And then we have MA, okay, which is 114 kilonewton meter. So the first one, what we need to do, we need to find the real structure. So remember, dalam nak buat ni, and then dalam nak cari ni, this is the real structures. And then the same thing we have to do, which is the third one is your virtual structures. So virtual structures, you akan cari smaller mi lah. This is mi capital, mi smaller. So here, so you have A, B, and C. So in this case, because kita nak cari vertical displacement at B, so kita hanya apply 1 kilonewton sahaja dekat point B. Alright. So, sampai step ni semua orang patut jelas. Adakah you all jelas? Emoji please. Kalau I tanya tu, I nak emoji je. I kan attention seeker. Okay. Alright. Good. Thank you. Alright. So bila you dah ada benda ni, what is your next stage? Your next stage, then you need to calculate. Okay, you need to calculate your real structures and your moment structures. So you pun bawa lah dia pergi ke the next one. Okay, here. Make it smaller sikit. So now, kita tahu step yang keempat. What is the step yang keempat?
Cari
Step.
setiap member.
Sorry?
Cari setiap member.
Cari setiap member. So you need to cut sections. So step yang keempat, so selalunya I akan minta you all buat, okay, you have member. Okay, and then I want you to draw a table. Okay, member, and then you need to have the region. Okay, member, region, and then you will have your MI And then you need to find what is your virtual MI. Okay, so in this case, so you have dalam soalan ni, okay, dalam soalan ni, you akan ada beberapa cara nak potong dia. Alright, so cara yang pertama, let me explain to you. Okay, kita go through one by one So, cara yang ke... Oops. Okay, the first cara you nak buat, okay, let's say kita ambil dia color merah. So, option 1. Option 1. So, you akan boleh potong from the right hand side, okay, X. And then you boleh potong daripada left hand side, X. Option 1. Option 2. Okay, option 2, what you can have, okay, untuk option 2, mungkin everything you wanted to start from the left hand side. So let's say you have here, so satu region, and then you akan ada dua region. Alright, so another option, maybe you nak buat daripada left hand side. So you nak buat left hand side, for instance, tak mana sini lah. Okay, left hand side. So maksudnya you nak buat dia X 1, X 2. So this would be possible for your option 3. Okay, I nak tanya you all. Option 1, option 2, option 3. Which one is your option? Option ni yang satu. 1 ke, 2 ke, 3? Random, cakap je.
3.
Saya 3.
Option 3. Lagi?
3.
3. Option 3. You tak rasa ke option 3 ni agak sukar?
Saya cuba dulu.
Saya satu lah.
Oh, satu-satu.
Saya buat satu.
Satu silap.
Saya
Ya.
paling faham 3.
Dah rasa satu.
Okay, doesn't matter what your option is, tetapi apa yang membezakan you dengan kawan you adalah kalau you pilih option 3, okay, kalau you buat option 3, dia akan ada sedikit at this particular point, okay, I tunjukkan beza. Perlukah I tunjuk sampai detail ke you all dah faham dah apa beza option 1, option 3? Faham dah kot? I tak perlu tunjuk sampai detail kan? Kan perlu tunjuk.
Tunjuk option 1 je kot.
Option 1, okay. Alright. So, for this one, okay, kalau you pilih option 1 is sebenarnya option yang paling cepat. Okay, option 1 adalah option paling cepat. Because in option 1, okay, option 1, you akan ada hanya 2 region, which means of course option 3 punya ada 2 region, tetapi dari segi nak calculate dia punya moment, option 1 is actually the most convenient one. Okay, so you akan ada member AB. Okay, you have member AB, and then you akan ada member CB. And then region untuk member AB adalah berapa? Tak tulis pula dah. Sekejap Berapa panjang dia 63. Okay, 6 3. Okay. So, region untuk member AB, okay, X adalah lebih besar daripada 0, kurang atau sama dengan 6. Okay. Untuk CB, X adalah lebih besar daripada 0, kurang atau sama dengan 3. Alright. So, untuk nak dapatkan you punya M yang besar, dia mudahlah. Sebab dalam kes ni, you akan ada, okay, we take out this one. Hold on. We go for option 1. I will take it option 1. So this one is your option 1. Okay. Okay. For option 1, okay. So sekarang ni untuk option 1, what you have, you will have this one. Okay, you akan ada this, and then you cut separuh kan. So maksudnya you akan ada dia punya loading, loading dia. You have like this. Okay. Alright. So here, kalau you tengok dekat option 1 ni, so kita letak siap-siap, you ada here, you ada 26 kilonewton. And then dekat sini, you ada 114 kilonewton meter. Alright. So now, bila you cut sini, you cut dekat X kan? So you have this. This is your X. So here, you akan ada MX. Am I right? Hello?
Yes.
Okay. So when you have the MX, so may I know what is the load here? Berapa load dekat sini? Sebab sekarang ni you cut dia separuh. So berapakah load dekat sini? Kalau kita tengok balik, okay. Kalau kita tengok balik soalan dia, sebab jarak dia tak ambil tadi. Okay. Alright. So sekarang ni, load dia tadi adalah 7 kilonewton per meter. So sekarang ni, bila you dah cut dia separuh, dekat sini, you berapakah load dekat sini? Sebab kalau dia full triangle, at B is 7 kilonewton per meter. Full triangle. Okay, I mean like if you have the full triangles, okay, so ini 7 kilonewton per meter. So sekarang ni kita cut dia in between. Maksudnya kita cut dia antara 0 hingga 6 meter. Okay, so this one is at B. But now we cut it up to half. So maksudnya when we cut it up to half, alright, so here, this is X. So you cannot assume that here also is 7. So it means that you need to find what is the load at this particular triangle. So maksudnya you kena calculate macam ratio sikit. So you kena tahu berapakah ketinggian Y dekat sini. Kalau sini 7, kalau X berapa? Boleh faham ke? Anyone?
Boleh.
Boleh.
Because you have X here, you have Y kat sini kan. Maksudnya kalau you ada panjang dia berapa ni? 6 meter. Okay. Kalau 6 meter, okay, 6 you sama dengan 7. Okay. If you have X, okay, what is your Y? Macam tu. So you kena buat ratio lah. Betul tak? So bila you buat ratio, you akan dapat dekat Y ni adalah bersamaan dengan 1.167X. So dekat sini, you adalah equivalent to 1.167X. So ketinggian dia adalah 1.167x. So daripada sini you can calculate your moment. So here, okay, hold on. Alamak, salah delete pula. Sekejap So dekat sini, so you boleh calculate, you boleh kira berapa you punya moment. So kita nak kira you punya moment. So kita buatlah submission moment at mana? At X. Okay. Submission moment at X clockwise positive equals to 0. So dalam kes ni you ada 114 kilonewton meter ikut jam, and then campur 26 darab dengan X. Okay, 26 darab dengan X lawan jam minus setengah darab dengan X darab dengan 1.167X darab dengan, we know that here adalah 2/3, sini adalah 1/3. So, you darab dengan 1/3X campur dengan MX plus MX equals to 0. So, bear in mind, this one is your force, this is your distance. So, from here, you will get what is your equations. So, here you akan dapat your MX equals to equations. Boleh faham ke? Boleh faham ke?
Boleh tak?
Boleh. Ada sesiapa yang tak faham sebab the load would be variety. Yes, Azmi. Sorry, Faris.
Doktor boleh explain balik yang kenapa kita tak boleh pakai load. Contohnya kalau ambil left hand side kan. Rasanya dia punya load dia 7 kN per meter. Tapi bila cut je kita tak boleh ambil 7 kN per meter.
Ni, kenapa I ambil 1.16? Okay, kenapa I ambil 1.16? Sebab kalau okay, kita rujuk dekat sini balik, dekat sini. Dekat sini kan you ada 26. Kita kan nak kira equation kita, region dia adalah antara X. X dia adalah between A to B. Maksudnya kita nak dapatkan equation of moment in between A, B. X lebih besar pada 0, kurang daripada 6. So maksudnya sini kan kalau total length this one is 0 to 6. But now we wanted to know what is the MX here. What is the equation MX kat sini? So bila you nak dapatkan you punya equation MX dekat sini, loading you dekat sini, kalau you ada triangular load, here is 7 kilonewton per meter. So kalau dekat sini kita dah kira ratio tadi 1.167x. Maksudnya ketinggian load dekat sini adalah 1.167 darab dengan, katakan X you ambil, you nak kira load dekat 3 meter. So you masukkan 3, you dapatlah load dekat 3 meter ni berapa. Sebab the distributions of triangular load is increased from 0 to 7 kilonewton per meter. Dia tak sama kalau you are calculating for a uniformly distributed load. Because for a uniformly distributed load, along the beam, the load will be similar. So maksudnya kalau you ada A dengan B, kalau dia kata 3 kilonewton per meter, maksudnya kalau panjang ni 6 meter, kalau dekat 3 meter pun dia masih 3 kilonewton. Kalau dia dekat 4 meter pun dia masih 3 kilonewton per meter. Tapi kalau dalam kes macam ni, sebab dia increasing. So maksudnya bila you nak cari whatever load dekat point X, you tak boleh guna 7. You kena cari apakah ratio dekat tengah-tengah, sebab you nak cari dekat X kan. So you can carilah Y sama dengan 1.167X buat kira ratio tadi. So 1.17X will represent at any length along the beam. Faham ke?
Maksud yang saya kurang jelas tu doktor, yang tu saya dapat 1.167X lah.
Tak dengar lah, macam mana?
Saya kurang jelas yang macam mana dapat 1.167.
You kena buat ratio. Maksudnya macam ni. Sekejap. Dah penuh pula. So you need to look into the ratio. So maksudnya kalau 7, okay, kalau 7 it is equals to 6, isn't it? Kalau y, so you need to find berapa dia punya, orang kata apa, you kena buat nisbah. This is 7, macam you kira ratio 7 dengan y, 6 dengan x.
Oh, faham.
Okay, you kena kira ratio 7 dengan y, okay, and then you have 6 with x. So you kena buatlah ratio dia. Boleh?
Boleh.
Then you dapat. Cuba you kira, dapat tak 1.167 tu?
Dapat.
Okay, so that is how you calculate the moment lah. So you dah dapatkan moment, you masukkan dekat sini, and then kalau untuk CB pun sama juga, cuma dia in the other directions. So still untuk CB pun you kena cari berapakah value kat sini, and of course dia sama je lah 1.667x, and here also dekat 1.667x. So you masukkan and ulang yang sama juga untuk you punya virtual structure. And finally, bila you dah kira, so you akan dapat your range. Okay, kalau you ambil kira left hand side dengan right hand side tadi, maksudnya let's say you are doing this. Hold on. Not this. Sekejap Okay, let's say if you are doing this, option 1. Okay, kalau you guna option 1, so you punya final equation, this would be your final equation untuk M, and this is for your another CB, and then this one you akan cut sama jugalah. Bila you guna region yang sama, untuk virtual pun you kena guna region yang sama. Okay, so this one you will have like this. Okay, X. So in this particular case, so you know what is the forces, you ada reaction, which is VA1, kejap, nak tengok value dia. VA1, VC0, MA6. Okay. So dekat sini you ada 1 kilonewton, 0 kilonewton, 6 kilonewton meter. So you have X dengan X. So finally you akan dapat this value. And bila dah dapat this value, okay, you got this value, you masukkan dalam you punya equation, and then make an integrations. So finally you akan dapat this solution. Understand? Boleh faham ke?
Boleh.
How about the rest? Too quiet? Okay, good. Amin, faham ke? Muhammad Al-Amin?
Faham doktor.
Okay, good. All right. So now, let's move on. If you have a what we call it, a frame structure. Okay, sekejap. Kalau kita ada frame structure, macam mana pula kita nak kira? Tadi kita ada hanya untuk beam. So now let's move on if we have a frame structure. Okay. So, oops. Okay. Okay, kita tengok ni Okay, sekarang ni kita bagi soalan frame pula. Okay. Alright. So for this one, we have a frame structure punya questions. Okay. So what we have here, okay. So kita nak determine the vertical displacement. Let me check what is the question. Okay, vertical displacement at B. Okay. The question is determine vertical displacement at B, okay, given EI equals to, what is the EI value? 36,000. Equals to 36,000 kilonewton meter. Alright. So, in these questions, okay, dalam soalan ni, so for you to calculate and for you to cut the section, dia ada banyak cara. Okay. So maksudnya, you can cut the sections, okay, like this. Hold on, I will show it to you. Okay. So, you boleh cut section. First kali, soalan ni, kalau you nak tengok, dia lebih, you ada cara pertama, you can cut the sections. Here is X. And then BD. Okay, you have another X. Okay. And then you have another X. Confusing warna kuning. I buat warna lain lah supaya you all tak confused. Let's choose blue. Blue. Okay. So kita ada kat sini. Okay. Satu X. And we can have another X. And then kita boleh cut another X. Okay, this is one option. Okay, so ni option 1. Option 1. So another options, you can start to calculate like this. Okay, you boleh buat here X. Okay, and then you boleh calculate daripada sini pula. X1 and the other X. So this one can be your option 2. And you do have another option where you can solve like this, would be option 3. You have X. Okay. And then you nak buat macam ni. X. Pun boleh juga. Okay, option 3. So, what I'm trying to say, okay, alright, kalau you ada frame, the frame can be cut either horizontal, okay, you boleh measure X dia secara horizontal, atau you boleh measure X dia secara vertical, atau you boleh measure X dia secara incline, parallel dengan dia punya structure. So kalau dalam frame ni you ada another option yang you boleh buat, which means let's say I put it here. Okay, kita ada this one. Okay, another option yang you boleh buat kalau you ada 3 option, and then you nak buat another option which is your option 4. Option 4. So untuk option 4, you boleh buat vertical. Maksudnya you boleh kira X dia vertical. So you potong satu macam tu. Your X, okay. And then you can have like this. X, potong macam tu. And then daripada sini you nak potong dia macam ni. Pun boleh juga. So if you look into these slides, you have so many options, and it's again depends on your understanding, and it again depends on your fundamental concept. So, and you always need to remember when you calculate the moment, okay, so your moment will be equals to force times with distance, and your distance again must be perpendicular. Itu you kena ingat. Okay, you kena ingat dia mesti perpendicular. Maksudnya kalau you memilih option 3, okay, so you have your force. Kalau dekat sini you akan ada force macam ni kan, you akan ada force, you akan ada horizontal, and then you akan ada moment. So bila you nak kira ni, option 3 ni sebenarnya susah. Sebab your force semua you kena tukar dia. Okay, you have to divert the force supaya you punya HA ni dia kena berada dalam inclined forces macam tu. And then your so then baru you boleh calculate sebab dia nak kena 90 degrees. So option 3 is really quite difficult because your load semua secara vertical. So walaupun your member slanting, your load is vertical. So I'm not advise you to cut it parallel to the beam incline macam ni. Sebab you nanti I takut you tersalah-salah angle. Meaning that you have the HA here, nanti you kena tukar dia jadi macam tu supaya dia 90 degree. So option 3 I rasa boleh buat tapi you merugikan masa sebab you nak kena cari angle, nak bagi dia jadi 90 degrees and so forth. So it's not a good option. And while you go for option 2, okay, option 2 is also good option. But in this particular case, your X, so you need to measure you need to measure pula you punya macam ni. You kena kira you punya horizontal. Okay, you kena ada you punya HA. Okay, darab dengan you punya ketinggian lah, your X. Tapi your ketinggian X you ni, you tak boleh ambil X macam ni je. Sebab you kena ada in terms of, dia akan jadi Y in terms of berapa X ketinggian dia ni. Macam you kena buat ratio tadi. Okay, you akan ada Y sama dengan berapa X. So dia pun akan jadi agak mengelirukan. So untuk option 3 dan option 4 boleh dilakukan, tetapi I tak advise sebab sekiranya kalau you betul-betul familiar untuk nak cari dia punya height, you mahir dengan ratio dan sebagainya, you boleh teruskan. Tapi kalau you tak mahir, avoid option 3 and option 4 because in this particular option 3 and option 4, you somehow rather you akan buang masa untuk nak cari reaction, buang masa nak cari dia punya angle dan sebagainya. Okay, so if I were you, I will go for option 1. Okay, sebab kalau I pergi option 2, what makes my life difficult here? It's not make my life difficult, but if I go for option 2, I will spend extra time in finding the reaction forces. Where actually if I go for option 1, I don't really need to find the reaction forces. You all boleh faham ke? Kalau you ambil option 2, you kena kira reaction. Okay, maksudnya tak ada masalah, boleh je nak kira reaction tu. Tapi you akan spend time lah nak kira reaction tu. Maksudnya you kena take moment at A, dapatkan VA dia berapa, HA dia berapa, MA dia berapa, then baru you boleh cut nak kira dekat sini kan. Tetapi kalau you go for option 1, okay, if you go for this option, you even tak perlu cari reaction pun, sebab when you cut the section, okay, untuk option 1, right, if you go for option 1, what you need to have, okay, you ambil daripada right hand side, so here you akan dapat, alright, so you akan ada 5 kilonewton per meter, and then you akan dapat X, you ada moment, you nak kena cari MX, that's it. And then you find what is summation moment at X clockwise positive equals to 0. So then you akan dapat your MX equals to berapa. And then you go for BD. Okay, so untuk BD, you akan draw balik. Macam tu lah, you akan draw. So you akan ada 5 kilonewton per meter. So here is your C, B, and here is your X. So you akan ada moment M, X. So here you akan ada, you punya region you adalah X lebih besar daripada 5 kurang daripada 7. So bila you nak kira sini, you akan kira lah summation moment at X clockwise positive equals to 0. So you have 5, okay, you dapatlah you punya MX sama dengan berapa. So what I'm trying to say, you have option 1, option 2, option 3 dengan option 4. So among all these option, okay, the fastest way for you to solve this question is by go to option 1. Because option 2, option 3, and option 4, you can do it, you can go for it. Some students, they love option 2. Doesn't matter, you can go for it. But you may need slightly few time extra compared to those who are answering by using option 1. But if you go for option 3, you might need more extra time compared to those who did for option 2 and option 1. And kalau you pergi option 4 lagi lah, sebab you kena kira ratio dia semua tu. Faham ke so far? Faham ke?
Faham tu.
Okay. Alright. Because sebab you dah faham, okay, my task for you, first, I nak you cuba selesaikan menggunakan option yang pertama. Kemudian, I nak you cuba selesaikan dengan menggunakan option yang ketiga. And then please time yourself, and you might find out that bila dalam virtual work method, the matter ataupun the time you need to read the questions is very important. What does it mean? It means that when you read the question, please spend extra time to think how to solve, to imagine how to solve the questions, how to cut the sections. Is it to cut like this, or is it to cut in option 2? So you need to think. You all kena ambil masa, baca, and then cuba fikir. Kalau you cut, you menggunakan option 2, what will cause you difficult? Kalau you ambil option 1, what cause you trouble? Okay? So samalah juga macam kalau you pilih tadi yang option, kejap kalau you pilih option 3, okay, option 3 dia akan memberikan you agak sukar. Kenapa saya kata dia akan agak sukar? You boleh buat, tapi you akan put a lot of effort for option 3. Why? Because you punya X tu, you ada X satu kat sini, region dia kan? And then you have another X region from here. So it means that bila you nak calculate this region, so the first cut, you akan ada cut macam ni. You will have these types of X. you akan ada X and then you need to find here. So here is 1.167X. Okay, you akan ada 1.167X. So you akan dapat you punya MX kat sini and then here you ada 2.5 kilonewton. And bila you nak, for this one, region you adalah X lebih besar pada 0 kurang daripada 3. Okay, 3. Bila you buat yang ini pula, okay, so you akan ada dua jenis load, okay, which means you have another load will be like this. Okay, kejap So here, so you have here 7 kilonewton per meter. Here you have 5 kilonewton per meter. So dalam kes ni, you kena cari berapa you punya value kat sini lah. Okay. So in this case, bila nak cari value kat sini, dekat sini, kalau you nak kira dia punya moment, kalau whoever yang ambil option 3 tadi, this is option 3. Okay, siapa yang ambil option ni tadi, you punya X tu adalah kira daripada sini ke sini. Okay, so bila you kira, so you ada 2.5 kilonewton. And then you nak kira you punya MX dekat sini. Alright, so bila you nak kira MX kat sini, again you need to find what is the Y here. So here would be berapa value dia. So bila nak kira, you ada trapezoidal load kat sini. So trapezoidal load ni, you kena bahagikan dia pula kepada 2. Sebab later on you nak add up. So in this case, your region, dia akan jadi X lebih besar daripada 3 kurang daripada 9 meter. Okay. So bila you nak kira MX dekat sini, dia tak, bukanlah I kata tak boleh. Boleh. Tapi dia akan jadi panjang sikit compare kalau you cut daripada sini dengan sini lah. Okay. So kalau you buat macam ni, apa yang nak kena kira? Submission moment at X clockwise positive equals to 0. So you akan ada negative 2.5 kali X. And then you akan ada plus setengah kali 3 kali 5 kali dengan X tolak 3. X tolak 3. No, sorry. X minus 2/3. Sebab sini is 2/3, isn't it? So X minus 2/3. Okay. 2/3 daripada 3. Alright. So then you nak kena calculate dekat sini pula. You akan, first you kena calculate untuk triangular load. Second you kena calculate untuk rectangular load. So you kena campur setengah kali. So you kena tahu pula bila you dah tahu Y kat sini berapa, untuk yang ini dia ketinggian dia adalah 7 tolak Y something lah. Kat sini berapa dapat. Okay, Y something. So sini pula ketinggian dia adalah Y tadi tu. So dia punya equation akan jadi rumit. So bila you nak masuk dalam calculator, nak buat integration nanti, dia akan jadi panjang you punya equation tu. Okay, so sebab tu I keep on saying in terms of the options. So please please try to look at the simplest way on how you can find a most simplest sectional moment equations to help you solve for the integration later on. Faham ke? Boleh faham ke? I perlukan pemahaman benda ni. Faham ke? Ada 2 orang je faham, yang lain tak faham. The rest, faham ke? Aisyah Hakilah, faham ke?
Faham, Miss.
Alright. Okay. Okay, good. Yes, Farizal.
Saya tak faham yang untuk frame option 3 tu.
Frame option?
3.
Frame option 3. Kat mana tak faham?
Yang dekat incline tu. Dia macam nak
Okay.
cari ya?
Dekat incline ni, kalau you pilih incline, sebab kalau you pilih incline, you akan jadi dia bukanlah salah, boleh, tapi dia akan jadi macam ni. Maksudnya bila you pilih incline, so you ada X you measure macam ni kan? Your X. So this is the first section cutting and this is the second section cutting. So kalau I kata moment adalah force kena perpendicular dengan distance. So kalau dalam kes ni kita tahu your forces adalah sini adalah you punya VA, sini adalah you punya HA. And then you akan ada moment kat sini, MA. Okay. So kalau bila you nak keluar, you nak draw this one kan. So you pun akan draw this calculation lah. You akan buat dia macam ni. So you have like this. Okay. And then you nak calculate. So you akan ada you punya VA kat sini. And then you akan ada you punya HA sini. And then you akan ada you punya moment kat sini. Moment MA. So now you nak cari you punya, sebab you potong dia macam ni. You potong dia X measured parallel. X you macam ni. So here is your MX. Okay. So sini you punya MX. So bila MX sekarang ni, none of your loading VA dengan HA, none of your loading adalah perpendicular dengan you punya distance X. So kalau you buat, kalau dalam solution ni you buat VA darab X, salah. Sebab VA dia bukan dekat 90 degrees angle of your X. So kalau you buat submission moment at X clockwise positive equals to 0. Kalau you buat VA darab X, HA plus, ikut jam lawan jam, minus HA darab X, and then lawan jam MA, and then lawan jam minus MX equals to 0. Ini salah. Sebab VA you ni, you kena resolve dia dulu. Maksudnya di sini, you kena resolvekan VA ni supaya dia berada, so dia akan jadi VA cos something, theta. HA, dia you kena resolvekan dia juga. HA cos something, okay, cos something, theta. So dekat sini barulah you boleh buat VA cos theta darab X. HA cos theta darab X. Baru you boleh buat equation tu. So dia jadi panjang. Bukan tak boleh buat. Boleh. Tapi kenapa nak make your life difficult? The first is better. You boleh direct calculate je. Tanpa cari your reaction forces. Faham ke?
Faham?
Okay. Alright, kejap. Ada pula lecturer masuk ni. Nak tak?
Doktor cakap apa tu?
Diam. Okay. Alright, so now semua orang jelas? Semua orang jelas ke? Okay, good. Okay, so now it's already 5 p.m. So what I want you to do before our class next session, sebab next session I target nak masuk composite dan lepas tu kita boleh start sikit-sikit moment distribution method. Okay, so for this one, I nak you solvekan soalan ini menggunakan option 1 dan juga option 3. Okay? Can you solve by using option 1 and option 3 and try to understand how it makes a difference when you choose a different solutions, different method, but at last it will yield with the same solutions. Boleh ke? Faham ke?
Faham, doktor.
Okay, alright. So, semua dah salin soalan tu tadi atau I perlu post dalam group?
Post dalam
grup.
Okay, I will post dalam group. So, nanti you all buat soalan tu. So, next I akan jumpa you all bila?
Monday online.
Monday kan? Okay. Alright, so everyone, our next class would be on, hold on. So tolong buat kalau I bagi, tolong bagi kerjasama, please do it because it's really help you. As I said, kalau you join me, you follow what I ask you to do, believe me, it will give you extra knowledge and it will give you more credit in terms of the exercise. So our next class would be on Monday, 11 November, 8 to 10 p.m. Everyone, 8 to 10 p.m. Monday online. Okay?
Ya, betul.
Okay,
Alright.
Doktor.
Okay, I think that's all for today. Thank you very much. I dah baik sikit, so I lebih bersemangat ya suara I compare to hari tu. I belum jumpa you all face to face lagi. Alright, thank
Betul,
you.
betul.
Thank you, Doktor.
Alright.
Thank you,
Terima
Doktor.
kasih,
Assalamualaikum.
Thank you,
Doktor.
doktor.
Thank you, Doktor.
Okay. Alright.
Thank you, Doktor.
Okay.